Hello and welcome. Uh, Today I wanted to show you the Mont Mégantic Observatoire, the Mont Mégantic Telescope in Canada. This is the first view from outside in winter. As always, first a little history and the equipment and geography, and from the results I didn't find so much. I will just tell you in which areas these researchers that are at the observatory are working, and in the end a very short summary. So the owners of this observatory are two Canadian universities that are actually quite close together, and the first light was in late April 1978. Then the observatory has seen some up and downs. For example, it had a finance crisis in 2012 and almost had to close. In 2024 they wrote that they got money for 2 more years. And they also built very important instruments there, but mainly for other telescopes. For example, the nearest spectrograph for the JWST. By the way, the picture I'm showing here is from the JWST, as you can easily see on these 6 ray stars here, but actually on the picture there are more galaxies than stars. This is the JWST deep field, which is an analogy to Hubble deep field, but as JWST has more size, it collects the data much faster than Hubble. The telescope there is a 1.6 meter Ritchey Chrétien Telescope, equipped with instruments for imaging, spectroscopy and polarimetry, as shown below. And they managed to make a dark sky preserve around the observatory, quite a large one, for 5,500 square kilometers. And there is also an astrolab for the public. Then some of the instruments that were or are used there. The CPOP here is an infrared camera going from the edge of the visible range till 2.5 microns. And then the spectrographic imager and a small visible range camera and a polarimeter. And as you see on the graph, it's quite conventional Ritchey Chrétien, so the detectors and instruments are behind the primary mirror. Then the geography, it's 45 north, so exactly in the west wind belt, and it's 1,100 meters above sea level. The problem is there are no larger mountains there, or at least no larger mountains that could be reached by car. So this was the highest, and there they built the observatory. The images in winter suggest that it's very, very high up, but it's actually just 1,100 meters. And I don't know anything about how many useful nights they have per year, or what is the seeing at this place. Then the results, if you look at the publication on the Institute's web pages, practically all of them were done with external observatories, which is impressive in itself. They worked with JWST and Keck and the ESO 3.6 that I've shown you a couple of days before. and also the Gemini South and telescopes in Las Campanas, and also the instruments on the WISE satellite. Probably I didn't mention all of them, and also if you look at the members of the institute is growing. So they have a good position in the scientific world. And this below is probably an overlay from a visible range and an infrared image. And because the credit is given to NASA, ESA, CSA, and STS, it's probably Hubble with JWST or something, this lovely galaxy picture. So the summary: the two institutes are important for the development of technology, also well networked within the infrared astronomy community. There's the Ritchey Institute for researching exoplanets. They research exoplanets and also planemos, which is a name for rogue planets. So planets that don't have a star, that just move around somewhere. And I didn't find a lot of data or image from the OMM telescope itself, but lots from external telescopes. And these are two more impressive images from the observatory. Very lovely pictures, but I would also have preferred to see pictures of the sky down in the observatory. So thanks a lot for the attention.